In this video, we're going to go over redox reactions. Now, you have actually seen a redox reaction before, you just might not have realized it. A redox reaction is a reduction and an oxidation reaction. So redox reactions are all about the movement of electrons. So a redox will be where you have electrons that are transferred from one thing to another. So when electrons are lost, we say that it's oxidized, and then when electrons are gained, we say it's reduced. Now, these two things have to happen together. So in order for something to gain electrons, you have to lose them first. So oxidation and reduction have to occur together. So anytime that you have an element that is by itself and then it becomes part of a compound, that is going to be a redox reaction. Now, not every single chemical reaction involves the transfer of electrons. Like double replacement reactions never involve the transfer of electrons because everything maintains its charge. So we say that the thing that is oxidized, so the species or the chemical or the element that is oxidized, is losing electrons. And that's also called the reducing agent because it's the thing that reduces the other item. The species that's being reduced is gaining electrons, and it's called the oxidizing agent. Well, the way that we keep track of what's being oxidized and what's being reduced is we look at the oxidation numbers. So an oxidation number is very similar to a charge. And in fact, if it has a charge, if the item has a charge, the charge and the oxidation number are the same thing. But not every single item in a compound will have a physical charge. So an oxidation number is more like a theoretical charge. So how do we get the oxidation number? Well, if it's got a charge, so if it's an ion, the charge of the ion is the oxidation number. So if I were to have aluminum with a +3, well, the oxidation number is also +3. So the charge and the oxidation number are the same thing. If an element is uncombined, so if it's by itself, so if you have any kind of metal by itself, or if you have a diatomic element by itself, when it's not in a compound, those will have an oxidation number of 0. So here it has a +3 because it has a charge. Here it does not have a charge, so the oxidation number is 0. So anytime that you have a compound, the oxidation numbers will equal the overall charge. So if I were to have aluminum chloride, all the oxidation numbers, just like the charges, will add up to the charge of the compound, which is 0 for this particular compound. So aluminum's got a charge of +3, chlorine is -1, and there's 3 of those. So +3 minus 1 times 3 added together will give me 0. Now if I have a polyatomic, like this, all of the oxidation numbers will add up to the charge of the polyatomic. So most elements are going to exhibit the oxidation number that their charge would be. So oxygen is usually going to be -2, group 1 is always going to be +1, group 2 is +2, the halogens are going to be -1 if they're in a compound. Now, the two exceptions that you really need to pay attention to would be oxygen and hydrogen. So oxygen is normally -2. But if it's in a peroxide, it's -1. Okay, so a peroxide is actually a polyatomic. It's an O2 molecule that has a charge of -2. So if it's hydrogen peroxide, like this, that would actually be a -1 for the oxidation number. The other exception is hydrogen. Hydrogen is normally going to be +1 because that's the normal charge for it. However, if it's a hydride, it's going to be -1. And you know it's going to be a hydride if it's bonding to a metal. So if I have something like this. So if it was positively charged, these two would not combine together. But it's actually -1. Hydrogen can actually be a +1 or a -1. So if I have, anytime I see this, this will be -1 for the oxidation number. In a binary compound with metals, essentially the oxidation number is the charge. All right, so let's look at determining the oxidation number here, because again, this is how we keep track if something is being oxidized or reduced. So is it losing electrons, is it gaining electrons? So potassium dichromate, so overall, all of these numbers, the oxidation numbers, will have to add up to 0. So potassium's in group 1, there's a rule for that, it's +1. Now, if I'm looking at this particular item, dichromate is a -2 charge. So everything in the dichromate has to add up to -2, or I can say everything in the compound has to add up to 0. Well, oxygen's rule is that it's -2 unless it's in a peroxide. This is not a peroxide, this is dichromate. So -2 multiplied by 7 will give me a -14 that I need to cancel out. Well, overall, the dichromate is going to be a -2. -14 plus what number will give me -2? Well, that's going to be a +12. And then if I look at the dichromate, chromium has 2 chromium ions here, or atoms. So each one has to be a +6. So for our oxidation numbers, potassium is +1, chromium is +6, oxygen is -2. All right, let's look at sulfur trioxide. This is not sulfite. Sulfite has to have a -2 charge. This is a neutral compound. Well, the rule for oxygen is it's normally -2, except in a peroxide. This is not a peroxide. There are 3 of those, so that's a -6 that I need to cancel out. There's only 1 sulfur, so each one has to be a +6. So sulfur is +6, oxygen is -2. Oh, this is a typo. This should be K2O2. This is a peroxide. It's potassium peroxide. So, since that is the exception, oxygen is not going to be -2, it's going to be -1, and potassium is +1. Usually when it's a peroxide, they will say the word peroxide somewhere in the problem. So, ammonium. Well, when we look at this, hydrogen is normally +1. It's not a hydride here, it's not bonding to a metal. So there are 4 of those, so that's a +4. So +4 plus what number will give me a +1, because it has to add up to the charge. So that would be a -3. So nitrogen here is -3, whoops, and hydrogen is +1. All right, so cobalt. Chlorine is normally -1. There's 6 of those, so that's a -6. -6 plus what number will give me -3, so that's a +3. Okay, so why do we care about this? When we look at a reaction and we are trying to determine if something has been oxidized or reduced, we look at the oxidation numbers. Did the oxidation number go down? It's reduced, which means you've gained electrons. Did the oxidation number go up? That means it's been oxidized, or you have lost electrons. So let's look at this particular reaction. I want to know what's being reduced, what's being oxidized. So the first thing you do is you determine the oxidation number for everything in the reaction. Okay, potassium is by itself here, so it's a 0. Chlorine is by itself, so it's a 0. So now I look at the compound. Chlorine is going to be -1. Potassium is +1. So if I look at this, potassium's oxidation number went from 0 to a +1. It went up. So that means that it's being oxidized. Chlorine went from a 0 to a -1, so the oxidation number went down. That means it's being reduced. Now, we can actually divide this reaction out into 2 separate reactions because it's a redox reaction since the oxidation numbers are changing. So there is an oxidation reaction and there's a reduction reaction. So I can divide these 2 things out into 2 separate reactions. So for oxidation, the thing that's oxidized is potassium. It goes from a K to a K+. Well, that's what's happening here. So when I look at this, well, I have one potassium, but I have a positive 1 charge on this side. So just like the atoms, when we balance a reaction, we have to look at the charges as well. So when you are looking at this, you're going to add electrons to the more positive side to make both sides have the same charge. I've got a positive 1 side on this, 0 on this side. This is the more positive side. I'm going to add 1 electron to that, and then it brings it down to a 0. Positive 1 plus the negative 1 for the electron would give me 0. So my reaction here is that potassium lost 1 electron. So now let's look at the reduction. Well, Cl2, so since it's a molecule, you keep it together. It's not an ion here. And it becomes Cl minus. Well, if I look on this side, I've got 2 chlorine atoms, so I need to have 2 on this side. So that's balanced, but now I need to look at the charge. Now I've got a negative 2 on this side, 0 on this side. So I go to the more positive side and I add electrons to make them the same. So I need it to be negative 2, so I'm going to add 2 electrons. So this would be my half reaction for reduction, and this is my reaction for oxidation. Now, technically, if I'm looking at this also, this would have to happen twice to get these 2 electrons to be gained. Okay, so let's look at another one. Okay, first thing, determine the oxidation number. So it's 0 for something that's by itself. Same thing for the O2, it's by itself. Now oxygen is going to be negative 2 here. Magnesium will be a positive 2. So now if I look at magnesium, it goes from 0 to a positive 2. The oxidation number went up. It is oxidized. Oxygen went from a 0 to a negative 2. It went down, so it's reduced. And also, since this is a molecule, we say it's O2. O2 has been reduced. Now let's look at the oxidation reaction. Well, magnesium was oxidized, so it went from Mg to Mg with a positive 2. Well, magnesium's balanced. Now we need to add electrons to the more positive side. So to bring this down to 0, I'm going to add 2 electrons. All right, now for reduction. Well, the O2 is a molecule, so I'm going to keep it together. Well, now I need to balance my number of atoms, so I've got 2. So 2 times negative 2 would be a negative 4 on this side. I've got a 0 on this side, so now I add electrons to my more positive side, so that's going to give me 4 electrons. 4 times the negative 1 would give me a negative 4. Alright, so let's look at this. Okay, magnesium is going to be 0 here. Hydrogen is positive 1. Chlorine is negative 1. Chlorine is also negative 1 here, because it's in a compound, but magnesium will be a positive 2. And hydrogen is now by itself, so it's a 0. Okay, so now we need to pay attention to only things where the redox number, or the oxidation number changes. So magnesium goes from a 0 to a positive 2. So the oxidation number went up, so it is oxidized. Hydrogen went from a positive 1 to a 0. So it went down, so that is the thing that's being reduced. So it's H+. So when it's an ion like this, we can say it's H+. We're not going to say HCl, okay? Because also notice here, Cl does not change its oxidation state. So Cl is actually a spectator. So when we're trying to decide what's being oxidized and what's being reduced, and you're trying to figure out, do I keep it as a compound or do I split it up? If it's part of a molecule, you leave it as a molecule. This right here, since it's an ion in the molecule, you separate it. So for instance, when you would not separate it would be if I have like a polyatomic. Let's say that the oxygens oxygen's oxidation number did not change, I would still leave it as permanganate because it's part of a polyatomic. All right, so now let's look at the half reaction for oxidation. Magnesium goes from 0 to +2. Magnesium's fine. I add electrons to the more positive side. Well, the half reaction for hydrogen goes from H+, and then it goes to a neutral molecule of H2. So it has 2 atoms, and that's balanced. So now I need to look at the charge. So now I've got a +2 on this side, 0 on this side, so I add electrons to the more positive side. So chlorine is left out here because it is a spectator. All right, now this is a special type of redox reaction. It's disproportionation. And essentially what this is where one thing in the reaction is actually oxidized and reduced at the same time. So when we look at this, oxygen has an oxidation number of -2. And here, chlorine would have to be a +1. +1, -2 gives me a -1 charge overall. So here, oxygen again is going to be -2, but the chlorine will actually be -2 times 3 would be -6. It has to be a +5 because again it has to add up to -1. And here this is just an ion, so it's -1. Well, if I look, oxygen is fine, it stays the same. But here the chlorine went from a +5, and then it also went to a -1. So it went down and up at the same time. So ClO minus becomes this. And then here, ClO minus also becomes this. So those are our actual 2 half reactions. And again, this is a polyatomic, so I'm not going to pull the chlorine out. If it's part of a polyatomic, you leave it as a polyatomic. So this is just a weird type of redox reaction where something is actually being reduced and oxidized at the same time.